All right, hi everyone. Today we're going to take a look at a question that was on the quarter 3 IA. We had a very low percentage of responses to this question, so I don't know if that's a matter of you weren't sure how to do it or if you just didn't have time to get to it. But then the percentage of people who did respond to this question, still we did not have a good percent of mastery for those students who did get to this question and who did submit a response. So we want to take some time today to review this material since this is a very important topic in statistics. It kind of is the culmination of a lot of things that we've learned this school year. And this unit in general, Unit 7 with confidence interval and significance testing, that is kind of the big to-do in statistics. It's really the combination of everything that we've learned. So let's go ahead and get started. So just as a reminder, please make sure you're taking notes on what we're talking about and submitting these to the daily exit ticket along with the CFUs from the Zoom call. All right, so let's get started. Activity trackers are electronic devices that people wear to record physical activity. Researchers wanted to estimate the mean number of steps taken on a typical workday for people working in New York City who wear such trackers. A random sample of 60 people working in New York City who wear an activity tracker was selected. So let's highlight this here. The number of steps taken on a typical workday for each person in the sample was recorded. The mean was 9,797, and the standard deviation was 2,313 steps. Construct and interpret a 99% confidence interval for the mean number of steps taken on a typical workday for all people working in New York City who wear an activity tracker. Okay, so we're trying to construct a 99% confidence interval, so we know that this value is going to be important, and it also asks us to not only construct but also interpret that interval. So we need to make sure that we are doing both parts of the question. So to start, we need to figure out what formula exactly we are using for this confidence interval. So if I go to my AP reference sheet on the third page, it has the formula that we have been using. The confidence interval is the statistic plus or minus the critical value times the sample standard deviation. So I need to figure out, am I looking at one sample or two? And am I looking at a mean or a proportion? So we need to answer those questions. One or two samples. And are we looking at mean or proportions here? So we kind of had a pre-step here. Step 0, more or less, was, are we looking at a significance test or are we looking at a confidence interval? And we already determined this is a confidence interval, so we know we're going to use this formula. So we kind of have 3 steps here to decide. So we've done the first step, so let's go back to the problem and figure out step 1 and 2. Rather 2 or 3. So looking at this sample, I only see that they're taking one sample, and that's here, just one random sample. So that is already going to eliminate some of the information here. So here it says single sample and 2 samples. So I know that it's not going to be 2 samples because we're only taking 1. So I've answered this question, I've answered this question, and now I need to look at here. Are we looking at a sample mean or a sample proportion? So going back to this problem here, it explicitly says the confidence interval for the mean number of steps taken. So that is going to be a mean here. Another clue was that we see standard deviation given, so that is also going to give a hint that we are looking at a sample mean. So therefore, this is the formula that I'm going to plug in to this half of the equation. So let's go ahead and record our formula. So we have the statistic. Let's just do our blank. So statistic plus or minus the critical value times the sample standard deviation. And we know that since this is a mean, our statistic is going to be x bar. We'll come back to the critical value in just a second, but we decided that the sample standard deviation was going to be sigma over the square root of n. Now the critical value here, we've gone over this many times, so hopefully you know what I'm going to ask you here. But based on the responses on the quarter 3 IA, most of us are still not getting this step correct. So we have to determine for our critical value, are we looking at a T or a Z for our critical value? Because that is going to dictate your confidence interval. If you pick a T when it should be a Z, you're not going to get the correct response or the correct interval. So we need to know when to use each. So for a sample mean only, we have this debacle. So for a sample mean, when we are determining the critical value, it could be a T or a Z. We know it's a T if the sample standard deviation is given, and we know it's a Z if the population standard deviation is given. So again, this comes from the sample. Sigma is the population standard deviation. So I need to go back to the problem and I need to figure out, is the standard deviation given a sample or the population value? So let's read carefully. So it says they took a random sample of 61 and they found the number of steps taken on a typical workday for each person in the sample was recorded. The mean was 9,797 and the standard deviation was 2,313. So, based on that, they're saying that these values here are coming from the sample. So that means we are going to use a T as our critical value instead of a Z, because the standard deviation is coming from the sample. So, now that we've determined what formula we're going to do, let's make sure that we can actually perform the formula. So let's go ahead and do our conditions here. So the first condition, randomness. This says a random sample was collected, so random sample taken. 2, do we have independence? Well, here we have 61 over, and this is for the people working in New York City. Well, New York City certainly has a lot of people working. Let's say that they have 1 million people. This is definitely going to be less than 10%, so we are good with independence here. And then our last one, normality. So I want you to pause the video and think, how do I determine if a sample is normal in a sample mean? Okay, so hopefully you got this correct. We've been talking about this a lot lately. We look at the sample size. So n here is 61, so that is definitely greater than or equal to 30, so we've met the normal condition. So now I can go ahead and just calculate my confidence interval. So let's look at our x bar here. So x bar is the sample mean, which was 9,797 plus or minus my critical value. So now I need to figure out the critical value. So let's go ahead and go to our T table, since we've already determined that this is a T for the critical value. So the two things that I need, 1, I need my degrees of freedom. 2, I need the confidence level. So here my degrees of freedom n minus 1, so that's 61 minus 1 gives us 60. And our confidence level was 99%. So let's go to row 60, and we want to look for 99% at the bottom here where it says confidence level. So 60 going across, and then here we get our critical value of 2.66. So again, the two things we need, degrees of freedom, n-1, and the confidence level, which here is 99%. We just find the intersection. So here we have 2.66. Let me just do an empty page. So we have our sample mean plus or minus 2.66 times our standard deviation, which the formula says sigma over the square root of n. But we don't have sigma, we have s. But that's okay, because since we said that the distribution is approximately normal, we're allowed to sub in s for sigma. So here we're going to just sub in our 2,313 over the square root of 61. So I could leave it like this, but I would highly recommend actually calculating this out. So let's go ahead and go to our calculator. So let's calculate the margin of error. So 2.66 times 2,313 divided by our square root of 61. So our margin of error is 787.76. So we can take our mean, 9.7, and subtract this value. And then we can take our mean again and add our margin of error. And this is going to be our interval. So our steps are between 9,009 and 10,050 or 584. So let's go ahead and record this. Okay. So 9,009. Let's just include 2 decimal places here. 0.24. To 10,584.76. Okay, so we've actually calculated the confidence interval. Well, what does this actually mean? Because remember, the two things here were to construct and interpret. So in the context of the problem, it says find the confidence interval for the mean number of steps taken on a typical workday for all working people in New York City who wear an activity tracker. So we can say we are 99% confident that the mean number of steps taken on a typical workday for all people working in New York City is between 9,009 and 10,584. So let's actually just record this. So we are 99% confident that the mean number of steps taken on a typical workday by all people working in New York City who wear an activity tracker is between 9,009.24 steps and 10,584.76 steps. And that's it. That's how we interpret it. All right, so there is a part B to this. And part B kind of goes one step further from the interpretation. So it says a wellness director at a company in New York City wants to investigate whether it's unusual for one person working in the city who wears an activity tracker to record approximately 8,500 steps on a typical workday. Is it appropriate to use the confidence interval found in Part A to conduct the investigation? Explain your answer. So they're essentially saying, if I take one person who's working in New York City and I find that their average number of steps is 8,500, can I use this confidence interval to conduct some sort of investigation and to say that this is unusual or this is okay? So we need to think. Our confidence interval tells us, and let's actually just go back to our interpretation. It tells us that the mean number of it tells us the prediction or the estimation for the mean number of steps taken on a typical workday by all people in New York City who wear an activity tracker. So the key part here is all people. So our confidence interval is for estimating a mean or a proportion about the whole population. So I can't make conclusions about individual samples, let alone individual people, based on the confidence interval. Because the confidence interval isn't meant to make conclusions about samples. It's meant to make conclusions about the population. So, in Part B here, is it appropriate to use the confidence interval to conduct the investigation? So we will say, no, it is not appropriate to use the confidence interval in Part A to make conclusions about individual samples, since confidence intervals estimate values about the overall population. All right, so I want you to really think about this question because this is something that the AP exam will most likely record and ask you about, because this is really understanding statistics in a nutshell. It's not enough to just be able to calculate a confidence interval. You need to actually know what it means. So you need to know how to interpret it, and you need to know how to apply it, when to apply it, and when not to apply it. All right, so with that, this is the end of the lecture. So please make sure that you're recording your notes and submitting it to the exit ticket file with the CFUs from the Zoom call, as well as the classwork packet from today that we will get started with together on the Zoom call. All right, so I will see you all on the Zoom call. Have a great rest of your day.